Hello, my name is Jan Levin. I am going to be a sophomore at Eastside Prep this fall, and this is my student ID card from last year. My first problem is going to be Module 2, application problem number 4. In this problem, we have a moving company, and in the moving company, employees must pass a training test. And employees who score within 18 points of 82 will pass the test. And we need to write a statement using absolute value notation that represents this problem. So starting off, X represents the score of the employee. Now, we start out with X, and it needs to be within a 12 within the score of 82. So let's subtract 82 from X, like so. Then we take the absolute value of all of that because X could be more than 82 or it could be less than 82. And we're just checking whether it's within 12 points of that. So the distance between X and 82 needs to be less than or equal to 12. And this is what this perfectly models the scenario. This is our answer. And now we can check our answer with a few edge cases. For example, if X was 70, and it would be the absolute value of 70 minus 82, 12, less than or equal to 12. So that would be negative 12 is in fact less than or equal to 12. Or if X was 94, then the absolute value of 94 minus 82 is in fact equal to 12 as well. So the two edge cases of this scenario would be 70 and 94. So the employees must score between 70 and 94 inclusive in order to pass the test. And overall, it is modeled by this statement over here. So that is Module 2, application problem number 4. Now moving on, we have Module 5, application problem number 4. So in this problem, we have a theme park, and it's designing a new roller coaster. And there are two people, Scott and Jake, who are submitting a design for this roller coaster. And they're modeling the roller coaster in the form of a polynomial, and they want at least 3 different turning points, and they want it to be downwards facing. So let's write this down. 3 at least. At least 3 turning points. And it needs to be downward facing. So Jake Jake thinks that the polynomial should have negative x cubed as a leading term, but Scott thinks that it should be positive x to the fourth instead. So first we need to see if either of them are right. If either of these are right. Let's sketch what negative x to the third would look like. It would look something like this. The roller coaster would look like this. It starts from the very top over here, and then it does a little curve and it goes all the way down. First of all, this only has 2 turning points, and we want at least 3 of them, so this automatically doesn't work. And in addition, there's nowhere to get on. If assuming the ground is here, riders can get off in this area, but this roller coaster extends infinitely upwards, and there's no spot to get on. So Jake is wrong. That it cannot be negative x cubed. What about Scott? He thinks it should be positive x to the fourth. Let's sketch that. It would look something like this. And if the ground was like here, for example, but on both sides, it extends infinitely into the air. So riders would not be able to get on or off. So this would not work either, but at least it does have 3 turning points, so at least it does meet one of the requirements. But there's nowhere to get on the roller coaster, so and it is not downward facing, it's upward facing. So this would not be a functional roller coaster. Now, I need to come up with a leading coefficient that I would use, and I say I would use negative x to the fourth as my leading coefficient, as my lead uh, as my leading term, and the leading coefficient would be negative something. And this negative x to the fourth as the leading term, when sketched out, it would look something like this. As you can see, it is both downwards facing if this is the ground, and it has 3 turning points. So this meets both of the requirements, and the end behavior of the thing that I chose would be as x approaches negative infinity, so x is going this way, y also approaches negative infinity, and as x approaches positive infinity, so as x goes this way, y also approaches negative infinity. So this roller coaster is downwards facing and it has 3 turning points. And this is a sketch of the example. So that is module 5, application problem number 4, done. Now moving on, the next problem will be from module 7. It's going to be application problem number 3. So we are looking at the concentration of a drug in a patient's bloodstream. And the input variable is going to be t, which is the number of minutes after the injection is given. 1 second. After the injection is given. So now, what do we do next? Let's write down the equation from the problem. It says that C of t is equal to 50t over t squared plus 25. So first we need to find the concentration of the drug 5 minutes after injection. So that would be C of 5 equals 50 times 5 over 5 squared plus 25. Simplifying this further, C of 5 equals 250 over 50. So C of 5 equals 5. So after 5 minutes, the concentration of the drug would be at at 5, level 5. The problem doesn't specify what level 5 means, but it would be at 5. Now, what about 10 minutes? Now we need to solve for C of 10 equals, looking back at the same, C of 10 equals 50 times 10 over 10 squared plus 25. So that means that C of 10 would equal 500 over 125. So C of 10 equals 4. So after 10 minutes, the concentration of the drug in the patient's bloodstream would be at a level of 4. Now, what does that mean? That means that it would be at a level of 4. Now, the horizontal asymptote is, when sketching a graph, the horizontal asymptote is where the end behavior of the graph is at the very is the end behavior of the graph at the very edges horizontally along the on when looking at the x values and y values. So the horizontal asymptote of C of t would be because looking at the equation, looking at the function, we see that C, let's rewrite it down here. C of t equals 50t over t squared plus 25. Notice that the degree of the denominator is over here. The degree of the denominator is 2, meanwhile the degree of the numerator is only 1, because it's t squared and t to the power of 1 here. So because of this property, the degree of the denominator is higher than the numerator, the horizontal asymptote is always y equals 0. So on a graph, that would look like the horizontal asymptote would just run along the x-axis like this, y equals 0. And finally, as t increases, the concentration of the drug will go down, as we can see. We can do a quick sketch of this using So first we notice that there is no vertical asymptote because uh, because no matter what t is, it is impossible to get the denominator to be 0 because t squared is going to be either 0 or positive, and then you're adding 25 to it. So the denominator is always going to be positive, and we can't have 0 be the denominator. So there are no vertical asymptotes. So now sketching a few points. So now we already found the points that that when t is 5, uh, the y value c of t is going to be 5. So we can label this as 5, 5. And then when c is 10, then c of t is going to be 4. So this will be 10, 4. So we can see that over time, as the concentration of t increases, the concentration of the drug goes downwards. So as t increases, c of t decreases. So that is Module 7, application problem number 3 solved. Now finally, let's look at Module 7, application problem number 4. We want to convert from x degree. So we know that the formula to convert x degrees Celsius, x degrees Celsius to y degrees Fahrenheit would be f of x equals 9 over 5x plus 32. So in this case, x is Celsius, and y and function of x, f of x equals Fahrenheit. Okay, now we need to find the inverse function where we can get from Fahrenheit to Celsius. So in order to do this, let's simplify this. Let's move things around in this original function. We can replace f of x with y for simplicity. So we're rewriting the original function as y equals 9 over 5x plus 32. And since we're finding the inverse, we swap x and y. So it becomes x equals 9 over 5y plus 32. Now let's swap sides for simplicity. So it is 9 over 5y plus 32 equals x. Let's subtract 32 from both sides. So it is 9 over 5y equals x minus 32. Now let's multiply both sides by 5 over 9. So we get y equals 5 over 9x minus 32 times 5, which is 160. So 160 over 9. So that is going to be our final answer for the inverse function of the formula given here. And the meaning of this is converting, and we can even rewrite this as f of x equals 5 over 9x minus 160 over 9. So the meaning of this here is that x equals Fahrenheit and f of x equals Celsius. So the original equation, we were converting from Celsius to Fahrenheit, and this converts Fahrenheit to Celsius. And I think that is it. That is solving. Sorry, 1 second. Let me double check my work for this last one. Mm, okay, so y equals, then subtract 32 from both sides, and then we multiply by 5 over 9. So we put in Fahrenheit, we multiply, and then we get Celsius. Yeah, and that looks like that is about it. And yeah, I've double checked my work, everything looks good. This is a function for converting Fahrenheit to Celsius, and that is all 4 of my application problems for the Free Calculus 1 midterm. or Pre-Calculus 1, Part 1, whatever the assignment was. So anyway, I hope you understood and thank you for watching. Bye.